Hi everybody, welcome to Learning the Program with Roblox Studio. I'm Aaron from the Funtime Games group on Roblox. And on our lesson that we're going over today is going to be about relational operators. And I've started out writing a script already, and we can go over that. And that will help you understand what relational operators are. And as you can see, I've written them all down below on line 3 here. And you can see the symbols, right? There's the less than, the greater than, the less than or equal to, greater than or equal to, not equal to. And those are going to be your relational operators. Now, how do you use them in code, right? Well, you may have recognized the equal to's. We've used that before on previous tutorials on learning the program. And those are commonly found on your conditional statements. So your if statements or your while statements are usually their home, right? So now, what we've seen before with the equal, we were comparing two words. So we'd say is this, and we have our literal statement or our quotes around it to make it a literal, string literal. Is this equal to this, right? And we're going to see is it's going to evaluate, and it's going to see if each position is equal to each other, right? So it's going to go through, and each position, each word, or each letter, and each spot is the same, and it's going to print out it works if it is, right? So we can go ahead and see, and we have once we hit play, we can see in our output it does print out it works. So the comparison's right? Now what if we hit, and this is the equal to operator or relational operator. So what if we hit is not equal to, and it's the tilde or tilde, then the equal sign, and that means not equal to. And you can get this this first symbol by pressing Shift, and there'll be a button on your top left under Escape. You'll see it with the same looking symbol on it, and you click the Shift and the tilde, and you should get the symbol, and then you just press the equal sign right after it, and that in Roblox or Lua means not equal to. So, and that means kind of just like how it sounds, right? When you're kind of comparing the two things here, is this not equal to this? And that's quite literally what we're saying. And so what happens if we're gonna compare it now, and we hit play, right? We said hit print it works if it works, if it's true, right? So the statement's not true, and we get no output, right? Because we didn't specify to give output if it wasn't true, right? So we can see that not equal to says that, hey, these two things aren't equal. And with relational operators, you're having basically to compare two things. So usually you're going to see it sandwiched between two items, and the two items can be various things when you compare, right? You could be comparing numbers. So if 5 is not equal to 7, we know that, right? But hey, the computers will figure it out too. Once we hit play, it says it works because 5 is not equal to 7. But another thing we can do is say 5 less than 7 is that, and that's going to evaluate to true, right? The computer's going to say 5 is less than 7, and all that this conditional operator is looking for is true or false, and then it'll do this statement. So we can see that's going to come out as true, and we could do is 5 greater than 7. If we hit play, this wouldn't print because 5 is not greater than 7, and this would evaluate to false. So in a way, our relational operators are a way to compare two things. And that's going to be another tool you can use, or more tools you can add to your toolbox when you're using if statements and while statements or while loops. And those are both two from our, as previous tutorials, our selection structure and our repetition structure of programming. So you can add these tools to both of them, right? So now we could say is 5 greater than or equal to 7, right? no, it's not greater than and it's not equal to, right? So it's going to be false, right? So this will print false. If I hit play, we can see that nothing prints, so it's false. So we could also say if 7 is greater than or equal to 7, right? What do you think is going to happen now if we print is 7 greater than or equal to 7? Let's find out, right? Let's hit play. It works, right? Because whenever you hear the word or, you want to think in a sense of if one of the conditions is true, they both are, right? Which means 7 isn't greater than 7, but 7 is equal to 7. So when we say is greater than or equal to, you want to set that in your head. The keyword or, usually in programming, is going to mean that there's going to be a set of conditions, right? There's going to be this or that, right? And this will probably be a future video on conditional operators, which is what or is, or I'm sorry, a logic operator, because it's more logic oriented, right? It'll add more of a compound statement that you can make in your conditions, right? Which, as you can see here, is it's kind of multiples. Just within this relational operator has a multiple, so it's kind of a compound operator right here too, if you think of it that way, because we're evaluating is 7 greater than or equal to, or again being the keyword, so that if one thing is equal in an or statement, the whole statement is true, right? Doesn't matter that 7 is not greater than 7. Once we say or, that means if the next statement is true, even though the first one is false, or vice versa, the whole statement is true, right? So this could be 7 could be, what that means is that this could be 8, right? Right? So 8 is not equal to 7, right? So that should be false, right? Well, remember we said greater than or equal to. So since it's greater than, we don't even have to really check the equal to, because if any one of the conditions is true, if it's greater than or equal to, the whole statement is true, right? So if we hit play on this, we'll see again, it's true because this instruction got ran, right? Which means this evaluated to true. So that's one thing to look out for, is the greater than or equal to, meaning either or, right? If either the first condition is greater than the second condition, or the second piece of information or data, then it's true. Or if 8 is equal to the second condition, the first condition is equal to the second condition, then it's true. So it could work either way. Again, the thing to remember, once you hear in your mind or, it's that you're going to have two things. If either one is true, the whole thing is true. Okay, and we'll go into that further on, but that's one thing of greater than or equal to, or less than or equal to. And that's one thing that's a little different on these two, the greater than or equal to, or less than or equal to, that are going to be a little different than the other conditional operators. And it's something to watch out for when you program. The other thing to watch out for is to make sure you're comparing the same data to the same data in a way. Some data you want to make sure you're comparing apples to apples and not apples to oranges. So what I mean by that is, and it's going to sound silly to you too once you hear it, but say if we say is 5 less than or equal to purple, you're like, what? Oh, it doesn't make any sense, right? The computer is going to think the same thing. So here you're probably going to see, since you can't really compare those two because they're two complete different data types, it's going to basically tell you the same thing. It's going to do it with an error. It's going to say you attempted to compare a number with a string, and that just doesn't work, right? It doesn't want to do that. Okay, So we can compare a string with a string, right? And what we're going to do here is I'm going to show you how you can do that with a string. A string relates two different ways, right? All right, we're going to say error is less than purple, less than or equal to purple. And this is going to be this is really a very complex statement. And we're going to say the statement is it works. Okay. So how do you know that error is either less than or equal to purple? Well, the thing here about string comparison is a little different than numeric comparison, because numeric is, well, I know that 5 is less than 7, right? That's easy. But how do you compare the two strings here? Error, and how is a string less than another string? Well, what's going on is that E is going to be evaluated, and say if we gave a number to E where it's positioned away from the first of the alphabet, so it's, if you can imagine A being 1, B being 2, C being 3, D being 4, E would be 5, right? And purple would come way after 5. So in the sense that the string error is less than purple gets evaluated, that becomes true. So the statement becomes true, right? How do I know this? How can I be sure that's how it works, right? Well, what I can do now is, instead of saying less than or equal to, I could say, well, if I want to make sure that's how it works, I could say, is it equal to, right? Is it just equal to? Well, and then I'll hit play, and you'll see that it doesn't print anything. So the equal statement there was false. So what if I said is less than now? And is this, so this is going to have to evaluate to true, right? Yeah. So that's how it evaluated to true. So why would it be less than but not equal to? Well, you can evaluate the strings by, you know, where it would come in alphabetical order, and that's what less than or equal to on a string comparison does. Or you could say equal to. And equal to is not going to compare the first thing in where it would appear in alphabetical order. It's going to say each character in the word or the string is equal to the next one, right? So error is not going to evaluate as being equal to purple, but there's only one thing that will, and it's purple, because each character in here is the same as the character in the last one. And if we hit play, we can see now that it prints it works, and that means this statement is true. So that's one thing to watch for as well, is how you're relating and comparing characters and strings using the greater than or less than. Usually I really haven't run into too much of a case where that you're going to use that much. Most of the time I'm looking at character comparison, it's going to be using the equal statement. But that's one thing to be aware of, is you want to make sure you're comparing your apples to apples, and that you don't get that error where you're trying to compare a number to a string. And that's one of the pitfalls of using relational operators to watch out for. So right now I want to go into, well, what can I use this for now? Why is this powerful? And I'm going to give a little example real quick of what it can do. And on this one, I'm going to create a variable called color, right? I'm going to say color is equal to blue. And I'm sorry. I'm going to assign a variable named color of the string blue, or the string blue. So, and another thing to watch out for, I think we went over this before, but this and this don't mean the same thing. Whenever I have one, it's what's known as an assignment operator. Whenever you have two, it becomes a relational operator. So there's almost like two different functions right here, right? This function or purpose means to take whatever to the right of this equation, evaluate it, and then assign it to color, right? So it looks at, it's just a literal, so it's going to say, okay, well, just send it over to blue, and it's going to assign it the color, or assign color the value blue, right? If I did this, this is trying to compare something, right? And there's really, you're going to have that little error there because color has not been defined in a way yet. It hasn't been assigned anything yet to compare, so it's just like a blank space. So what we're going to do now, though, is we're going to create the blue, right? And we're going to see, okay, and we're going to set a statement that's going to be true. So, but how we're going to do it is we're going to use one of our operators. We're going to say, we'll try it this time with not equal to, right? We're going to say if color is not equal to what? We're going to say red. So if color is anything but red, right? So not equal to red, then we're going to make these instructions down here. Now, what do I want to do, right? Now that I was able to create a statement that said, anything but, right? That's pretty powerful, right? We can make a select, tell the computer select anything but. In here comes what I like to call the power of really your imagination, because when you work on Roblox, you have access to so many things. You have 3D objects, you have sounds, you have animations, and each of those you can affect with basically what comes next in this block, or what kind of code you want. So I'll show you an example of that. Is that, well, now we've shown the power of what we can do by saying telling the computer to select anything that's not equal to red, right? So I said, okay, it's blue. Now we're gonna run this code. It made a selection. So what do I want to do now? Well, let's say write some pseudocode down here to see what we want to do, right? And pseudocode just basically means that it's pseudo means kind of, the word means fake, so it's like fake code. But I always do this when I program a lot, and it's kind of how I was taught was, you kind of want to speak out your instructions, or basically write down what you want it to do in plain English, and then you kind of want to relate that in the computer. So what we want to do, and since we're starting to write a little bit more and more code on our examples, we're going to write a pseudocode for it. It says, and we'll write down basically what we've created already. We say if color is any color except blue, or except red, I'm sorry. And that's what that means here. If color is not equal to red, which means any color other than red, or any string other than the string red in here will evaluate to true, right? So what that means is that's how we would say, right? If any word, we could say if any word, but we'll call it color, right? And except red, then so if the variable color is any color except red, then what, right? Then make everything, or we'll say make every part with the color property, or the brick color property, in the workspace red, or blue, I'm sorry. So now we can see that, okay, so if this, then we're gonna make every part in the workspace blue. Okay, so we kind of wrote what we want to do here, right? So now we kind of have to look at, how would we do that in the code? How does our words relate to creating that code of what we want to do? So we could say make every part with brick color property, and that's one thing that's kind of, you always want to kind of make sure of, because I knew ahead of time that we're going to make probably a loop, right? We're going to have to go through all the parts in the workspace, figure out, make a list of them, and then figure out which ones have a color property that we can affect and change, right? Because if you go ahead and make this loop, and then you're saying to tell the computer to, hey, change the color property on this, and that object doesn't have a color property, it's going to throw an error, right? Your script's not going to work. So that's always something you got to watch out for. So I kind of know that going into it ahead of time, but It's something that you kind of have to count ahead for in a way, and you will get that in time as you start programming more and more, especially with Roblox and Lua. So how would we do this? Okay, so we want to make every part. So basically we have a selection here. It says every part. So what's every part? Well, it's these on the right, right? So we want it's these things. They have all these things called brick color, right? If we look at terrain, terrain doesn't have a thing called brick color, or a property called brick color. Camera doesn't have a brick color. So we don't want to change or affect the color of that, because it's just going to throw an error if you try to. So for the first step is we want every part, right? So we'll just make a list of every part. Now, how do we do that? So we'll create a list, and we'll call it list of parts. And how do we get that? Well, our things are in workspace, right? All the things we want are under workspace. So every part, if we look at our text, in the workspace, right? So that's kind of like, you can kind of see the words every part and then in workspace. So we want a list, right? So we'll create a list of parts. So we'll say workspace dot, I'm sorry, not dot. We want a function that will make us a list of all the children in workspace, right? So one thing that will do that is get children, right? And again, we can see the open and close parentheses, which signify its function, and again the colon signifies it's a function of workspace. And this is actually a more common function I use a lot. And what it's going to do is it's going to get all these parts here and all these, the terrain and camera, which we don't want, but it's going to get everything under here and create a list of them and return it. So what's going to happen, we have our assignment operator, so it's going to say go create this list and return. The function is going to return the list. So we're going to be left with, once we evaluate everything here, a list of everything, of all the children under workspace, right? And that's going to be assigned to list of parts. So our list of parts is going to have the value of all these things. So what do we want to do now? We just want everything that has the brick color property. So now that we have a list of everything, we want to separate out the things we need to use, and so we can affect only the parts we want. And how do we say that? Is so we want to make sure we have every part with the brick color property in workspace, right? So we would say that we would create a loop, right? Because we've just created a list. Now we want to go through each one by one. The best way to do that is always going to be a loop. So, and we'll probably go over the more example of this in the future, but just so you know that you may not have to understand what it means now, but we're basically going to run through this, all the list of parts here, right? And we're going to run through each one by one, and the value inside each is going to be k, right? The part value I'm going to need is going to be known as k now within this loop statement, the for statement. So for each time it runs, k is going to be something different. It's going to be the next part on the list, right? So one loop may be base plate. The next time it runs through the loop, it's going to go to the next part on the list, right? But it's going to start with all of them, right? It's going to go through camera, terrain, base plate, part. So since it's going to do that, well, I need to not make it go through camera or terrain, right? I need to make sure that it knows I want to change the color of every part blue, except it has to have the brick color property. So here's where we say if, right? If the current part we're looking at we're going to say if it's a base part, right? That's a way to say a base part has brick property, right? And these are all base parts, right? You can see how the symbols are different, and that's one quick way to separate what we want, right, in the code is and using by another function called isA, right? And that's pretty similar to how we would say in English that if the object K, if the thing I'm looking at in the list, right, if it's a base part, is because the camera is not a base part, then we want to change the color to blue, right? We just got to add that later, right? But as we're looking at it here, we'd say if K and then is a base part. So on the loop, we're going to go to camera. Is camera a base part? No, right? So then whatever we put in here is not going to get run. So it's not going to see that to check if k.brickcolor receives a new brick color blue. That's not going to be, that instruction is not going to be run. So that's exactly what we want, right? So if K is not a base part, then it's not going to be run. And again, you can see base part by the symbol here. You could see how terrain has a different symbol, and base part is simply meaning that it's an object in the world we've created either by adding a part here and clicking that, and we could add that just now. It won't matter. We haven't run our code yet, so we could keep adding if we wanted to these parts, and we can make sure they're anchored because these are floating now because I put them in the air. Or by a mesh we import, which we'll probably learn later. So if I go back to this right here, and I go back to my script, and I say K is a base part, then what do I want to do? I want to make it blue, right? That's what I said, right? So we'll make it blue. So say K dot, and it still has the right. We're still accessing the list part, right? So we're going down as part, and part still has, if we click on, just like if we clicked on it, it has property still, and one of those properties is going to be brick color, right? So we can still say brick color. Yep, move this out of the way. Brick color receives, and we're going to give it a new brick color, right? And a brick color is again one of those data objects that has a larger data set. So we basically have to create an object so we can create data to pass on to the property, right? Because if we look at the property, brick color, it has like a name, and it's probably going to have a RGB color behind that to know what color it is. So it has multiple sets of data in it. So whenever we come across that, we're usually going to have to create a new object to create all that new data and put it in an order that brick color, the property brick color, can understand, right? So, and what it understands is we can create it by calling the name, right? We could say blue, right? And we might get baby blue, deep blue, and really blue is the one I was after, right? So we see there, you can put it in the string surrounded by the quotes. So you have a really with a capital R, and then a space, and then lowercase b for blue, right? So what's this going to do now, right? Oh, and I forgot something here. You can see I have the red mark right here, and I forgot a do, right? It's because I'm creating a for loop. You always want to put that do there, right? To just like you would the then and if. If this is true, then do this. For all this in the statement, do these instructions. So you want to have that do there, right? I missed that. So usually the case if you see the next statement in the list of instructions underscored red. So you want to make sure you have that. And if we run this right now, what's going to happen? Well, if color, if this variable is any color except red, it is, then we're going to do this. And what is this? Make every part with the brick color property in the workspace blue, right? And that was basically just off the top of my head, and you could see that every brick space, or every brick and object that's a base part in the in the workspace is blue now. Right? So it really, the beauty of Roblox is that anything after this all these relational operators that check your condition if it's true, everything in here that you want is based on your imagination, right? The instructions you give it or your imagination. Because when I started programming, I had text, and all I could do was print out text. And although it was pretty neat, and I still stuck with it, I always wish they would have something like this when I had learned programming, because I would love it to have that impact on a 3D object in a 3D world. So with so much power that I could change properties of it, I could change positions, create animations, basically create a whole world and really affect that world with what I wanted it to do. And what you want it to do is this instruction in here, right? You can go in there, create the world. You can go in there and create it with code if you wanted to. We did that on our last tutorial. We created the steps for the obby with our code, with a few lines of code. You could simply change things, and you could do the same thing with the code, and it becomes so much more powerful because it's basically everything you want to do or create. You really have at your fingertips here, because you can create a whole world and then affect it with your code. And relational operators are just another thing in your toolbox where now you have a little more power to do comparisons and to create comparisons in your if statements, or your conditional statements in your if statement. So in that way, you get a lot more power that way. But for the next one, you're still going to want to learn your logic operators, and those will make even more, one more next level of things you can do with your conditional statement, right? So sometimes you want to have more of a compound statement, like we went over with a less than or equal to, right? Sometimes you want to say, what if two statements have to be true? And we'll probably go over that next time. And as always, if you have any questions, any comments, if something wasn't clear, if there's something else you want me to go over, please leave them in the comments down below the video. And as always, thank you for watching. Have a good day.